Okay, let's start the to solve the problem. Okay, so this is the problems on thermodynamics. The problem is two blocks of the same metal having same mass and temperature T1 and T2 respectively are brought in contact with each other and allowed to attain thermal equilibrium at constant pressure. The change in entropy delta S for this process is, four options are given. So here two blocks of the same metal and same mass having temperature T1 and T2, they are brought in contact with each other and allowed to attain thermal equilibrium at constant pressure. Okay, so suppose this is two block A and B. Okay, two block A and B. This is A and this is B. Okay, identical block of same metal, same mass. Okay, and its temperature is suppose T1 and temperature of the B block is T2, and also suppose that T2 is greater than T1. Okay, assume that T2 is greater than T1. Okay, so when these two blocks are allowed to contact with each other, okay, suppose this block is connected to this block. Okay, then what happened? And the system attain thermal equilibrium. The system attain thermal equilibrium. Okay, so the temperature, final temperature will be, the final temperature for each block will be T final equal to T1 plus T2 by 2. Okay, because the system, whole system is in thermal equilibrium. That means the two blocks, the final temperature of the two blocks will be same, and that will be T1 plus T2 by 2. Okay, now we know that we have to find what? You can see the problem, that is change in entropy. Change in entropy, we have to find the change in entropy. Now what is entropy? We know that entropy, we know this expression, ds, S is entropy, equal to dq by temperature. Okay, that is equal to dq means Cp dt, dq means Cp dt divided by T. Okay, so if we integrate this, okay, Cp is constant, and integrate this. Okay, so here integration from S1 to S2, or we can write S initial to S final, and here also T initial to T final where T final is equal to T1 plus T2 by 2. Okay, we already explained this, that the final temperature is equal to T1 plus T2 by 2 because the system attain thermal equilibrium. Okay, so after integration, what we get? After integration we get SF minus SI, SF minus SI, okay, that is equal to delta S. Okay, so delta S equal to Cp integration d2 dt by t, that is ln Tf by Ti. Okay, right? Okay, so we get the expression for delta S of each block. So this is the general expression, this is the general expression, delta S equal to delta S equal to Cp ln Tf by Ti. Okay, this is the general expression. Now for block A, okay, for block A, delta S1, suppose the entropy change is delta S1. So for block A, delta S1 will be Cp ln Tf. Tf means what is Tf? Tf equal to T1 plus T2 by 2. Okay, so here Tf, we can substitute this T1 plus T2 by 2, and what is T initial? Initial temperature is for S1, for the first block, that is block A, it will be T1, right? So this is the expression of entropy change for block A. And for block B, similarly delta S2 is equal to Cp ln, final temperature will be T1 plus T2 by 2, and initial temperature for block B is T2. Okay, so total entropy change, that is delta S is equal to delta S1 plus delta S2. Okay, so we have to add this to this one and this one. Okay, this one and this one. So after adding we get, that is Cp, after adding these two, okay, just shift here. Okay, so this will be Cp ln T1 plus T2 by 2T1 plus ln T1 plus T2 by 2T2. Okay, so the option will be option A, right? Option A. So it will be Cp ln T1 plus T2 whole square by 4 T1 T2. Cp ln T1 plus T2 whole square by 4 T1 T2. 4 T1 T2. Okay, and this will be in bracket, right? Okay, so this is option A. So option A is the correct option. Okay, again I revise the problem, that is two blocks of same metal having same mass and at temperature T1 and T2 respectively are brought in contact with each other and allowed to attain thermal equilibrium at constant pressure. We have to find the change in entropy of the overall process. Okay, so as the system attain thermal equilibrium, so the final temperature will be the average of temperature of the two block, that is block A T1 plus block B T2 by 2. Okay, so we have to apply the formula for calculating the entropy change, that is delta S equal to Cp ln T final by T initial. So putting the value of final and initial temperature for each block and then sum up the two entropy change for block A and block B, we are calculating the total entropy change delta S, that is equal to delta S1 and delta S2. Okay, so this type of problem may be asked in competitive exams like NEET, JEE Main or other competitive exam in physical chemistry section, thermodynamics section. Okay, so the students carefully calculate and systematically solve this type of problem. Okay.